Welcome to ERC Technology. In this video, we will be learning voltage drops calculation in a series circuit. Let's say that we want to determine the voltage drops at R1, R2, R3, and R4 as given on this circuit. And we have three voltage sources of 20 volts for VS1, 100 volts for VS2, and VS3 60 volts, all connected in the same direction with the plus minus polarities. Now let's write first what are the given in this circuit. So let me write first here the voltage sources. So we have three voltage sources, VS1, VS2, and VS3. And VS1, VS2, VS3 are all given here as 20 volts, 100 volts for VS2, and VS3 is given as 60 volts. That's it. And then we will be writing the available resistances. We have R1, R2, R3, R4, and these are equal to the following ohms. The first one is equal to 20 ohms. The second one is 40. The third resistance is 50 ohms. And the last one is equal to 10 ohms. Now that we have written the given values, we will be writing what's the required or what do we want to do here in this particular problem. As you can see in the question, we are supposed to calculate for the voltage drops at resistances R1, R2, and R3. So we need to get the voltage drops at R1, R2, and R3. Or we can also say V1, V2, and V3. That's what we want to calculate here. So to solve this problem, let's analyze the voltage sources first. So the first thing that you should do is to find the voltage source total, or we can write VS tot or VT, or that's equal to the sum of the three voltages VS1, VS2, and VS3. So again, I'll write it here, the total source voltage, which is also written as VSTOT or VS tot or VT, or equal to VS1 plus VS2 plus VS3. So let's substitute the values of the voltage sources given. So VT will be equal to the first voltage source, which is all voltage sources are in the same direction. So 20 plus 100 plus 60 volts. So let's use the calculator. 20 plus 100 plus 60 equals 180 volts. So that's it. This is our total voltage source or VT. Again, you may write it VST or VT or VS tot. Now the second one is to find the total resistance RT. So we have to add the resistances R1, R2, R3, and R4. So 20 plus 40 plus 50 plus 10, that would give us a value of 120 ohms. So now we got the total R or total resistance. The third thing that you will do is to find the total current in the circuit. So let's call it IT. So the IT by Ohm's law is equal to V over R, or V total over R total. Our V total is 180 volts and our R total is 120 ohms. So volt over ohm is equal to ampere or A, and calculating this we got 1.5 amperes for our I total. Now the next step is to find the currents on each resistors, and because this is connected in series, we all know that in series there's only one current Therefore, whatever I total we have calculated, that will also be the values of I1, I2, I3, and I4. And so with this idea, we can write I1 equals IT, or I1 equals 1.5 amperes. Same thing with the I2, I3, and I4. They will all be equal to the I total of 1.5 amperes. Again, this is possible because we have resistors in one path or one line. That's the series resistors. So we can consider that the currents are the same. Now for the last part, we will calculate the voltage drops. So we write V1 equals I1 R1, V2 I2 R2, V3 equals I3 R3, and V4 equals I4 R4. Substituting the values of the current and resistances, we will get 1.5 multiplied by 20, 1.5 multiplied by 40, multiplied by 50, and multiplied by 10 ohms. And so by using the calculator, let's get the values of this. It would give us 30 volts for V1, and then 60 volts for V2, 75 volts for V3, and 15 volts for V4. Now we got the voltage drops across R1, R2, R3, and R4. That's it. So you need to practice calculating in order to remember these things. You may do the same problem again, but do not look on the solution. You can pause this video and try it. So to summarize, we have the following answers. V1 equals 30 volts, V2 60, V3 75 volts, and V4 15. Now, if you try to add these voltages or these voltage drops, what would be the value? So 30 plus 60 plus 75 plus 15 would give us 180, which is exactly the same as the total source voltage, or VT. And this is what we call as KVL, or Kirchhoff's voltage law. Again, to summarize, we have this circuit with 3 voltage sources and 4 resistors, and we have connected the voltage sources in the same direction. So that's easy because we will just add them, no subtraction. And then we calculated for the total voltage source because there are 3 voltage sources. We have to simplify it to 1, and we got 180 after adding all of them. Secondly, we got the total resistance by getting the sum of the resistances. Because they are all in series, we will just add it also. Thirdly, we get by Ohm's law, I equals V over R. We got the I total equals to VT over RT of 1.5 amperes. And last, we mentioned that the currents for all the resistors are the same or equal to I total. So we don't need to calculate anything there. And finally, the voltages were calculated by multiplying the currents of the resistors to its resistances individually. And so we got this answer, which is also the sum, or the sum is equal to the total voltage source. So we think that our answer is correct. Thank you. Please subscribe.